Good afternoon, everyone, and thank you for joining us. I'm Andrew Glass. I'm a member of the CFEE group, Carbon-Free Residential Everything Electric, and also the president of the Friends of Modern Architecture Lincoln. And the two groups are very happy that you're joining them for this sustainability weekend. And I wanted to start by thanking Colette Sizer, our fearless leader of CFREE, and Belinda Gingrich and Jen Curtin for organizing today's event, and our coaches that you'll meet in a moment after we hear some presentations from them. And I think you'll find today very informative about thinking about how you can start shaping your own house to make it more sustainable, to move away from fossil fuels and help us all collectively ensure a more positive future for our planet. I wanted to say a little bit about the connection between CFREE and FOMA. FOMA, of course, is an entity that's committed to education and preservation about our built environment. And we're very fortunate in Lincoln to have a collection of over 300 modern homes that began in 1937. So there's a long history of architects who designed homes with a focus and an understanding about sustainability. They built small homes that used new technologies, often to keep the price of the homes down. And they understood the importance of the natural environment and opening the homes up to nature and using design to expand the feeling of the home by borrowing views from one interior space to another, by borrowing views out into the landscape that we're fortunate to have in Lincoln, to create a sense of well-being and also to not have to overbuild. As these houses are approaching now their 90th birthdays, the oldest houses in Lincoln, which is a remarkable thing to think about. FOMA also began to think about its preservation mission and how we can keep these houses going for another century. And in doing that, really thought about the importance of keeping all of our built environment functioning well and harnessing the ideas of the modern architects that were really important to that aspect of Lincoln's history, which is a continued commitment to understanding new technologies and how they can benefit society, understanding the importance of not overbuilding, keeping houses small, trying to preserve houses where you can so that you're not releasing embedded carbon into the atmosphere, and also understanding ourselves as a community and how we can promote not only single-family homes, but multifamily homes, building on our tradition here in Lincoln of Lincoln Woods with housing concentrated around transit stations so that we can create vibrant, walkable and bikeable communities and keep the sense of nature and our close connection to nature alive and thriving. Again, I wanted to thank you all very much for joining us today. And if you're able to join us on our tours tomorrow, we also look forward to welcoming you to the house tours. And I think today you'll hear ideas from very knowledgeable people about how you can start the thought process for yourselves. And tomorrow, we have 3 homeowners who are very generously opening their homes, and you'll see a range of approaches to how people have actually began to implement the ideas that you'll hear about today. So we're very excited for the Sustainability Weekend, and I'm pleased to turn over the floor to Jen Curtin, our Assistant Director of Land Planning.
All right. Hello, everyone. I am Jennifer Curtin. I'm the Assistant Director of Planning and Land Use for the town of Lincoln. When I was working on the climate action plan, among many others, worked on it in 2023, the most common thing that we heard from folks was that they were interested in green energy technologies, but they did not know where to start or who to trust to give them assistance. It is very daunting to figure out yourself how to get from where you are now to where you want to be, especially when it is a large project like transitioning your home technologies. This is why we're holding this workshop. So you can create a plan that'll help you feel more comfortable when it does come time to take that step. Having a plan is very critical for your success, regardless of your current situation or your current goals. Some people are ready now to transition to different technologies, which is awesome. But even if you are not ready now, this planning will be especially beneficial. For example, having a plan to replace your furnace with a heat pump before your furnace dies, rather than just replacing it in kind, will mean that the stress from the transition will be eliminated or greatly reduced. And maybe you're just here for some more information, which we welcome you here as well. No matter where you are, this workshop will help you connect with other like-minded fellow residents. And you will have helpful neighbors to help you walk through the process. You will be hearing various presentations from different residents and their learned experience, lessons learned, and their successes they found with transitioning to green energy technologies. And finally, if you are interested in one-on-one free coaching through our Green Energy Coaches program, I welcome you to fill out a waiver and sign up with your name, and we can give you more information. The volunteer coaches are here to provide support, assistance, and help you work through your plans so that you can achieve your green energy goals. And so with that, I will turn it over to the presentations and welcome Michael Moody.
Hey, welcome everybody. Well, good introductions all around. They set the stage, so I'll jump right in. We moved to Lincoln about 10 years ago, and we ended up with a house that needed a lot of work. It was pretty much an energy disaster. So I started looking around how to approach it, and started thinking, well, what are the reasons I want to do this? Well, reducing emissions from heating and cooling. I don't need to tell you what's going on with the planet, but it's disastrous, and we need to stop our contribution to that as much as possible. If we can weatherize our home really well, we reduce, and before the transition from fossil fuels to electric, you reduce the size of the equipment you need and the cost of it. Great savings right there. Plus, you reduce your heating and cooling costs long term. So two really significant savings if you spend money up front to weatherize your home well. And higher electricity costs are almost certainly coming, so this is the right move. Okay, so when I started thinking about this, I'd been following this stuff for a number of years, and I knew about the Pretty Good House group. There are builders in Maine working on finding ways to build better homes, especially with a focus on energy efficiency. They were familiar with the passive house standard, which is basically, in a strange way to say it, insulate your house so well you can heat it with a candle. I mean, it's not quite like that, but practically, they really, really insulate the house super well. These guys and gals said, you know what, that's possible, but it gets really complicated and really expensive if you take it to that level. So if we pull back a little bit, how far back to where it stops making real sense to add insulation and put in fancy windows and so forth, how can we get to, almost that far for less money? So that was what I chose as my goal. Okay, so here we've got the Pretty Good House column on the left, and then our Pretty Bad House. So they call for triple pane windows. We had all single pane on the lower level and good double panes on the upper level. Blessings on the people who left them before us. So those were good. Under the slab, nobody puts foam under slab until very recently. So of course we had nothing there. Foundation walls, they call for 3 inches of foam or 3.5 inches of fiberglass. we had almost nothing in the wall, foundation walls. Underexposed floors, deck houses, that's what we're in, a deck house. There's a 2-foot overhang all the way around the house. That's not insulated in deck houses. So in the wintertime, when you stand near an outside wall, your feet are cold as heck because, you know, just 3 inches below you is, you know, 0 degrees or whatever. So we had nothing, no insulation there. In the walls, they call for 3.5 inches of fiberglass and 3.5 inches of foam. So really good insulation. In our house, 1-inch fiberglass. That was what they did in the 60s, maybe 1.5. And then 6-inch fiberglass in an addition that those wonderful people left us. Roofs, they call for 8.5 inches of foam in a modern home with a cathedral ceiling. We had about 2.5 inches. We don't have a vented attic, but just so you know, they call for 18 inches of cellulose in that. And then air changes per hour, that basically says how many times in an hour does all the air in your house get blown out by wind pressure, whatever, and replaced, and you have to heat it. So a lot of houses are 10, 15, 20 times every hour you're reheating the air in your house. That's like 20 to 40% of your heating bill goes out the window or through the walls. So they call for 5. We were at 6, which wasn't too bad. All right. So we jumped into this, and I found a really awesome guy down in Millis through a friend who'd been in this business for 40 years. And here's what he helped us do. So we got triple pane on the lower level, and then we kept the double panes upstairs. Under the slab, we couldn't get anything under it, but in one room, we were able to do 1 inch of foam over it. I'll show you a picture of that. Foundation walls, we got 4 inches of foam. We were already doing some drainage around the foundation, so we put the foam outside. Under the exposed floors, we got 4 inches of foam. In the walls, it varies all over the place. Some walls we just couldn't access. There was all built-ins or, you know, bathroom tile or whatever. So there's some places that's still the original 1.5 inches, but it's not much. So we go all the way from that up to R37, where we basically meet or beat their requirement. And we got 7.5 inches of foam, almost met their goal there. And we brought our air changes per hour down to 5. So it really, really made a difference. Okay, so like I said, windows, the lower level, does this my cursor show here? No, it doesn't. Lower level, all triple pane, upper level, they're good double panes. You don't see any air sealing here, but we did a lot of air sealing. And we didn't see that much change from 6 changes per hour to 5. And I think there's a reason for that inherent in the design of the deck houses, that I'm trying to do an experiment to prove that. So we did as much as we could there. But air sealing, very, very important. Okay, here's the laundry room there with a cork floor. You can see the tile outside it and about a 1.5 inches or so bump up. So we have 1 inch of foam on top of the concrete floor. It was just an ugly concrete floor. So now we have a nice new cork floor and some insulation there. And we have, you know, some thick carpets too, which also help in other rooms. Okay, here you see the that 4 inches at the bottom of the left-hand side of the corner there. That trim is hiding the 4 inches of foam that we put in. And you would see it on the end, except we replaced the siding there, so it doesn't show up. So this end of the house only had 2 windows. So here we went whole hog. We took off the siding, added 4 inches of foam, put the siding back on, and then rehung the windows. It would have been completely impractical in the rest of the house with the size and number of windows. But that wall is pretty simple. So that changed that wall from R6 to R30. So a big jump. You can see with the ruler there, the windows are the walls are about 9 inches thick. That's because of the basic stud wall and then the 4 inches of foam outside. So that's on the lower level. Okay, and then finally, here's on the left is the original roof line of the house, very thin profile to the edge of the roof. And on the right is the current roof. So it's about 6 inches thicker than what it was before. Okay, so deck houses have lots of windows and big windows. So that's where we lose most of our heat. Even though they're good windows, they still leak a lot. So note this, that white vertical plastic line right by the ruler. that's a sidetrack for cellular shade. So some companies sell these. It basically seals up the edge of the window when the cellular shade is down. So then you get like an R that adds R 3.3 to a window. So an average double pane window with that is better than a triple pane. So we added this in 4 rooms. In seldom used rooms, they stay down all winter. So it really makes a difference. And we've also been exploring, we haven't bought any yet, these called Windcerts from a company in Boulder called Windcerts. And some of them even have low E glass in them. They're in sort of interior storms and they can slide into windows. Very, very little labor costs on those. So that's a huge savings. They can turn a double pane window, even maybe a single pane. I still have my doubts about that, but into a good window. Okay, benefits. So we put on rooftop solar at the same time, and we put in mini split heat pumps, which are very efficient. So everything was electric except domestic hot water and cooking. And we had no electric bills for 4 years. That's a really nice benefit. And then we bought an EV, and sadly, we had to pay electric bills again. So it's just more than our solar collectors could handle. But the power we purchase is 100% renewable through Lincoln Green Energy Choice, so no emissions from that. So not paying any electric bills, that's really, I loved it. Lessons, set high goals for efficiency when you're starting a process. Do what you reasonably can in accessible locations. Like I said, you got a wall that's tiled and you can't deal with everything from the outside. You live with that. And don't try to reach 100% if 80 or 90% is enough. And then plan the sequence carefully. Air sealing first, that's super important. Like I said, if you start insulating, then you've covered the areas that you want to air seal, and you're not going to be able to get to them. So air seal first, and then spread out the work as required by financial and bandwidth limits. And, it can go on for 10 years. You do it at your own pace. So there you have it. We can talk with you individually, and I'm happy to take any individual questions, but I'll turn it over now to Tom.
You're almost queued up and I'll get started. I'm Tom Longnecker. I've been a Lincoln resident for 28 years. And 26 years ago, I had the opportunity to move out of my mother-in-law's and build my own house in Lincoln. So I was pleased to be able to start living in Lincoln on my own with a pretty good house, to make reference to Michael's new construction. So many of the things he said about sealing and so forth were given from my house from the start. But there were a lot of opportunities still ahead. So I'll go into those. So that's my house on Baker Farm. More recent than when it was originally constructed. It's already showing some of the improvements that I've got. So we started with a pretty good house. And for us, what that meant was that it was, of course, modeled after my 8th grade math class project where I designed a house. But it did have some other features. At the time, I was starting a family, so we wanted to make our construction easy and meet some of our goals. So we went with the Acorn Deck House Company because they could build a lot of the house in a factory and then bring it on site and make a really tightly sealed home, which we appreciated. It also keeps costs down and wastes down, and it's a lot of benefits to it. The house was designed with passive solar in mind. We've got a lot of southern glass and really benefit from that light and the views. With all that glass, we made sure we had double pane glass at the time. We're pleased 26 years later that the vast majority of those windows are still in good shape. And when we had a window expert come in to say, should we address a few windows that are failing? They said, no, it's not going to make as much difference as you might think. So we got good news to just wait on that one until we have more windows to do all at once. During construction, we asked for as much insulation as we could get. So we had our 3.5-inch walls with an additional rigid insulation on the inside. So we got pretty good insulation on our walls. We filled our home with Energy Star appliances, making sure the appliances were as efficient as we could get. And then we kind of ran out of the ability to really think things through fully. We went with our dream of a wood stove in the house. We love the aesthetics. We love the warmth. When it came to this real heating of the house, though, we settled on the easy option of a oil furnace. Granted, it was with a forced hot air system, but the furnace was the easiest choice for us at the time, and our water was heated by propane. Not ideal for us, but we went with it because that's what we could handle at the time. Come on, there we go. Since building, we had many years of opportunity to improve some things, so we made sure that we brought in Mass Save and got their consultation about what we could do to improve things. As a result, we have more insulation in our attic. In fact, they offered an incentive to put in a certain amount, and we were able to get even more than that insulation blown into our attic. We have resealed our doors, which I think makes a good difference after a number of years. Put in our smart thermostats. When appliances died, we replaced them with other efficient appliances. As Michael said, cellular shades, a quick purchase from Home Depot seems to make a pretty good difference in terms of just a little more insulation on those windows. And we, as one of our improvements, reduce the amount of lawn that we have to mow. So that's my wife digging up the lawn so we can put in a big garden in the back of the house instead of a lawn itself. Less mowing, we figured, was a step in the right direction. But then we got into the serious stuff, the more expensive stuff. We realized electrification was a goal. In 2007, we installed solar. We were delighted when we did it. We got 18-panel photovoltaic array with a capacity of 3.1 kilowatts, which for those of you who know the modern systems, that's not so impressive. But at the time, it resulted in some positive, we were not paying for electricity for a couple of years. We also put in 3 thermal panels so that we preheated the hot water that went into our propane water heater to reduce the amount of propane we use there. And the nice thing is they said that these systems do pay for themselves in time. So we've definitely paid for those systems and now we're getting pretty cheap hot water and free electricity much of the time. Moving on with our electrification goals, we decided to drive electric. We bought a Nissan Leaf in 2012, and that allowed me to do all my commuting electrically. Love it. We installed the 220-volt charger in our home, so it was really convenient and fast to recharge as needed. Overnight was no problem. But once we put the charger in our house, we never saw another net positive electric production. We are paying for electricity again. The biggest improvement, I think, for us was when we anticipated that our 20-year-old furnace would be dying soon. We started doing some research. There was a HeatSmart event in Concord where we went and learned about the various options like wood pellet stove heating system, the air source heat pumps heating systems. And we figured out ground source heat pumps work well for our property, partly because we already had the ducting for forced hot air. But I love the idea that in a ground source heat pump, none of the energy that you're putting into it is actually creating the heat. All the other systems you have to create the heat. We were just harvesting the heat from the ground. All of the energy that's required is just moving it around, pumps and fans. That sounded pretty super efficient. I was skeptical when I first heard, could it really be that true, that it's that efficient? But results seem to be pretty good for us. Also love the idea that once we go to ground source heat pump, we are no longer burning any heating oil for our home. That was really appealing. One of the unexpected benefits was I don't need an oil tank in my workshop in the basement anymore. That was a lot of ground space I gained back from that. The whole system requires less maintenance than an oil system, certainly. And as advertised, we have lower costs for heating our home. Perhaps half as much as we originally paid. What I didn't anticipate in putting in a ground source heat pump was that they do have to drill some wells. So there was a major disruption to our front lawn at one point, but we saw the positives in that. And that led to some new landscaping, a new patio that we didn't have, a change to our deck, and we are delighted with that. The only exterior evidence of our heating system is our new landscaping. There are no other exterior systems like with the air source heat pumps. You can see something on the outside of the buildings typically, or even inside the buildings. None of that's visible for the ground source heat pump. Inside, this is now look at our water furnace unit, which fits in the exact same footprint as the oil burner that we use for our system. So that was an easy trade out there. Because of the engineering that they did in planning for the system, they realized that we needed some more ducting in our basement to deliver the heat where it needs to be. And as a result, all of our house is comfortable now instead of just some of it. They did a nice job with that. And I credit the engineering as much as the ground source heat pump for that. The reality is for our house with the wood stove, we were burning about 400 gallons of oil a year to heat our home, which wasn't a lot, but when it's over $1,200 that we were paying at the time, it was something we would rather not do. And instead of burning the oil, we were moving heat around. So we did see our electrical bills go up between the pumps in the ground source heat pump and the increased blowing of the hot air system. Our electrical bills did go up. We figure about $600 a year devoted to our heating system. But that is half of what we were paying for our oil each year. And it's not adding any emissions to the system, to the overall. So we were very pleased with that. And now we can say, both with our solar panels and the system we're using, we have a house that uses sustainable energy. We went with the Lincoln Green Energy Choice, 100% renewable. Encourage everyone to seriously consider that. We have our own solar. I did look into whether we could get one of the newer, more efficient systems. And yes, of course, they would welcome our money for that. But I also got the recommendation it's probably not worth taking down a functional system until you need a new roof. So we'll save on that replacement. And we make efforts to conserve electricity, hang our laundry. We do actually look at how much electricity our appliances draw, and we turn off loads. So there are basic things we're doing. But we're not done. There's still more ahead. When our appliances wear out, we'll make sure that we replace them with efficient ones. What I'm looking forward to when it's time to replace our propane water heater, we will go with a heat pump water heater, no question. When we need to replace our gas stove, I'm looking forward to working with induction. I've tried it. I like it. When our asphalt roof dies, we're going to put on the metal edge roof that we won't have to replace again, and makes it really easy to put the solar panels on. Someday, if I can collaborate with some neighbors, I'll buy an electric mower, maybe a wood pellet grill. We've got a lot of things to look forward to. I'm also offering my services as a green energy coach because I think everyone should look at whether there's an opportunity for improvement. And then, of course, there are some other choices, ways to conserve emissions, reduce emissions in the future. So thank you very much. And Chuck Sizer is available for our next presentation.
My name is Chuck Sizer, and this is my wife who introduced me and has guided me along the way. And this is really a repeat of Michael Moody's, because I got most of my information from Michael and then followed his plan. So we moved into Lincoln about 12 years ago. We have a mid-century modern house built in 55, so it actually a little predates it. And it's a really small house. It's 1,100 square feet and very open and nice contemporary architecture. We really like living there, but it had a really bad carbon footprint. So we had a lot of work to do. So the first thing we did is we said, where are we now? And we took a look, and we looked at the heat loss using an FLIR camera, so you can see exactly what heat is being lost. Then we assembled the data on our energy usage, and our therms of gas was 800 per year, which is a lot. That's 80,000 BTUs. We were using 7,700 kilowatt hours of electricity. And then for our car, we're using about 300 gallons of gas a year. And if we convert it to electricity, strictly based on those units, then this is what it would come out. It would come out 23,000 kilowatt hours for the heat. And that is converting electricity by resistance heating directly into heat. And it doesn't figure in the heat pump. So that's direct conversion. Then 7,700 kilowatts of electricity is, of course, 7,700 kilowatts of electricity. 30 gallons of gas turns out to be about 2,000 kilowatt hours of electricity. So that's what we require for a car, an electric Leaf car. So we decided the first thing we're going to do is, since we have a roof that needs replacing, we're going to replace the roof. We had about an R6 roof. And so we followed Michael's example. We put on 6 inches of polyiso. Yes, sorry. So we put on about 6 inches of R5.5 polyiso cyanurate. And that brought us to an R value of about 33 for the roof. And then we put a new roof on, and then we had the photovoltaic conversion units mounted on that. And the structural part of the house was somewhat limited, and we could only put on a maximum of 32 solar panels. And as it turned out, we had to cut that back to 28 because we also had a chimney that was getting in the way. So we ended up with 28 panels at 400 watts per panel, and that gave us a total of about 10.8 kilowatt hours, which is a pretty good amount of electricity. So we used the steps that Michael recommended. Number one, we fixed the envelope. Number two, we removed the gas furnace, installed a heat pump. And this was one of the most difficult things that there was, because we didn't know how big the heat pump needed to be. You know, it was before we added insulation and so forth. We just had the history. So we had to correctly size the heat pump. And what we did is we estimated the heat loss to the roof, through the windows, et cetera. And then we came up with, we need about a 3-ton unit. And as it turned out, we had ample capacity with 3 tons. So this is one of the most difficult decisions we had to make. Then we also removed our gas water heater, and we installed an electric resistance heater. And that was probably a mistake because it's not very efficient. And if we had to do it again, we would probably go with localized heat pumps. Very, very small, on demand, and on timers. You know, for example, we do laundry on Saturday. Why keep hot water going to that 7 days a week? Turn it on Saturday morning and do your laundry. So there's a lot of decisions you can make. A lot of it involves timing. The other thing we did is we had the same issues on the roof profile. We were worried, is this going to affect the appearance of the house? And in fact, it doesn't. We put the insulation on, nobody noticed. So that was an easy decision, or a good decision. That's true. Yeah. So this is with a R1 window, and then with an R 2.7 window. The rest of the house we did with R8 windows. So the one on the left is with an R1 window with a plastic insert for insulation, and on the right is an R8 window. And those are from a European supplier, and they have inert gas in them. They're very, very effective. So when you stand by the window, you don't feel any cold air coming off it or anything. So they're extremely effective. We did the same thing in the kitchen. We replaced it with R8 windows, and we still have good circulation if we want to open the windows, and the appearance is much, much better. And then the conversion to solar energy, we estimated our heat usage. We installed the solar array and turned it on, and then we got the electric car, and we're now converting the solar into energy for the car. And as it turns out, what we do is we plug it in the daytime, and we don't we use entirely electrical energy to charge the car, and it worked out really well. And This is a typical day for us on heat charging. We get about, on average, about 60 kilowatt hours of electricity. And that's a pretty good amount. So we're pretty happy with that. It peaks at about noon, and it gets worse in the winter and much better in the summer. But in average, it works out pretty well. And this is a picture of our solar array, and we are in somewhat of a bad position for the optimal solar. Ideally, you would have 180-degree south facing roof with a steep angle. We're at a 17-degree angle and we're at 170 degrees. So we have an optimum efficiency of about 80%. That's the best we can do. So we live with it, but it's still pretty good. And this is the, well, no, let me let you take this one.
Michael was kind enough to provide us with this recent data that the cost of solar has dropped dramatically over the years. So if you think about solar and you think, well, it's way too expensive, the costs have dropped. 2010, it was 40K. For the same system today, it would be 18.
Yeah.
And we found that the pricing was extremely reasonable considering the tax incentives that we got for the system.
We had 400 watts per square meter, and now they're much over 400 watts per square meter. Tom, you had 200 watts per square meter. So, you know, it's going up quite nicely. Actually, I think it's plateauing right now, but pretty good conversion. So that's about 40% conversion of energy, which is really good. And then the last thing we did is we had to install heat pump. And we looked at the ground source heat pump, and unfortunately our house is on top of a cliff and we couldn't get a truck up there to drill the hole. So we had to go with air source, and we just got lucky on this. We located this on the east side of the house. So in the wintertime, the sun comes up and that area warms up and we get really good conversion. So it just happened out there, worked out really well. This is the 3-ton Mitsubishi unit, and we ran efficiencies on it even on cold days when it was -13 below. And at -13 below, we had at least equivalent to just energy, electrical conversion to BTUs. So we were running a coefficient performance of 4.6, which is pretty good. 3.4 is a direct conversion of electricity into heat. So we're really satisfied with that. The other thing that we did, since we had existing gas energy with a ducted system, what we did is we converted that to the heat pump. And there you see have the outside, the refrigerant, and then on the inside we have the fan with the heat exchanger on the inside. And the thing I like about the ducted system is that we also have a filter, and this removes all of the allergens. Very high efficiency filter, and we're really pleased that we kept our ducted system. The other option is to go with mini splits. Mini splits are a little bit higher in efficiency, but they have some limitations. Both mini splits and the ducted systems have good aspects and bad aspects, so you have to make a decision. So that's basically it. Thank you very much.